All right, today what we're going to be talking about is solving square root equations. So before we were talking about graphing them, so now we're going to solve them. So when you think about it, it makes sense because you're just doing inverse operations to undo it. But the biggest thing is you're going to get the radical term by itself. So if you look at your example right here, we want to get this term by itself. So we need to move this to the other side by subtracting 2. And then once we subtract 2, and we've got the radical by itself, now we can square this side, and we're going to square this side. So the square and the square root, it's undone because we undo the square root by squaring it. So these cancel out, and you're just left with x plus 4. Now be careful, because remember, it's all of this written twice. So you're going to distribute, and then you're going to get x squared minus 4x plus 4, which simplifies to x squared minus 5x equals 0. So then you're going to get x times x minus 5 equals 0, and then set each equal to 0, and then you have your answers of 0 and 5. Now, these are possible solutions of 0 and 5. Now, it's very important that you check your solutions to see if it's extraneous. So an extraneous solution is a false solution. So when you're checking, you're only going to use the positive root. So you do it because there's no plus or minus symbol in front of the radical of the original. So we're going to substitute in our value to wherever you saw x in the original equation. And then when we simplify it, we're getting square root of 4 plus 2 equals 0. So this is 2 plus 2 equals 0. Well, 4 does not equal 0, so that's false. So therefore, we do not use 0 because it's extraneous. So now let's try this solution by substituting that in for x into your original equation. And then you're going to get square root of 9 plus 2 equals 5. So 3 plus 2 equals 5. 5 equals 5. That is true. So therefore, 5 is your solution. All right, let's get started with this first part. So again, we want to get the square root all by itself. So we need to take this and move it to the other side by adding 3. Now that we got that, we're left with the square root of 4x plus 8. And it equals 4. So we need to get rid of that radical by squaring everything on this side. And remember, to keep it balanced, what you do on one side, got to do it on the other. So we square both sides. Your radical and your square cancel each other out, so you're just left with 4x plus 8 equals 16. Go ahead, subtract 8, and then you get 4x equals 8. Divide both sides by 4, and x equals 2. Now, we need to check this first. So what I'm going to do is I'm going to take 2, and I'm going to substitute it in wherever you see x. So I've got 4 times 2 plus 8, all under the radical, minus 3 equals 4. And then don't forget to bring this down. So I've got 8 plus 8, which is 16. And then I'm bringing down the rest of it. And now, square root of 16 is 4. Remember, we're just doing the positive root. Minus 3 plus 1, so I get 1 equals 1. So since that is true, this is a solution. So x equals 2. So you either see it like that or you'll see it written like that. All right, so now let's go ahead. Let's try this one. So in this case, we're going to move the 24 over here by adding 24. And then if you notice, the 8 is outside the radical. So we're actually going to divide both sides by 8 first, and you're going to get square root of x equals 3. Now, this is the only part that has a radical, so we only need to square this part, and then what you do here, you gotta do here, and you'll get x equals 9. So before we say it's okay, we gotta make sure we check it. And wherever you see x, you're going to substitute in 9. So I've got 8 times 3 minus 24 equals 0. This gives me 24 minus 24 equals 0. That is true, so this is a solution. All right, so now let's check this one. We have to move this x over to that side so we can get this part by itself. So now that we've added x over here, we're going to get x minus 2, and then we are left with this part here, which is square root of x squared minus 4. So now that the radical is isolated, we're going to square both sides, and you've got x squared minus 4 equals, now remember, this is really x minus 2 times x minus 2, so you need to distribute, and that's where I got my x squared minus 4x plus 4. And we're going to move everything over to one side, or the variables over to one side. So I'm going to go through, I'm going to subtract. Hey, look at that. That actually cancels out. So I'm left with negative 4 equals negative 4x plus 4. Now we can go ahead. You can subtract 4. You're going to get negative 8 equals negative 4x. Divide both sides by negative 4. And x equals 2. So remember, before you say it's a solution, we got to check it. So we're going to do 2 squared minus 4. Well, this is 4 minus 4, which is 0. And then we're going to bring, and make sure you substituted 2 into this x right here. And then we're going to bring all this down. And square root of 0 is 0. So I'm left with negative 2 equals negative 2. Well, that's true. So this is a solution. All right, and let's check this one. Now, this one, I've got x equals, and your radical's already isolated. So since it's already isolated, we can go ahead and just square it right away. And you're going to get x squared equals 42 minus x. So now, since we have, here we didn't have to set it equal to 0 because your x squared's canceled out and you're just left with the x. But here, since you have an x squared and an x, you have to set it equal to 0 to solve. So you're going to go ahead, you're going to move everything to the other side by subtracting 42 and adding x. And that's what you got here to move it over here. Set it equal to 0. And then go ahead, factor this however you like. And I got x plus 7 and x minus 6 equals 0. Set them both equal to 0. So I got x equals negative 7 and x equals 6. Now you can already tell, because I've already done the work there, which answer is going to work. But now let's prove it. So first I'm going to take negative 7, and wherever I see x, I'm going to substitute that into the original equation. So I've got my 42 plus 7 here, which is 49. So I've got the square root of 49, which is positive 7, because we're doing the positive root. But here it says negative 7 equals 7. Well, that's not true. So that's why this one is crossed out. So now let's check to see if 6 is a solution. So wherever you see x, we're substituting in 6. And I've got 42 minus 6, which is 36. And then square root of 36 is 6. So 6 does equal 6, and that would be the solution. Now, if for some reason neither works, if neither solution works, I'll put this down here. Then that means no solution. All right, so just be careful when you're doing this. Don't just say, oh yeah, one answer works, so, or one doesn't work, so the other one must work. You need to check both answers. All right, so now let's go here. I'm gonna have you try this one, and I'm gonna have you try this one to see how you do, but the hint, this one's actually pretty easy. You just square both sides, and that's going to be easier. This one, you got to watch out for that guy, because when you square it, it's really x minus 7 times x minus 7. So remember to distribute. And then here, when you square it, it's going to cancel out. You have 3x minus 21. So go ahead, try those two. Now this one, number 7, is a long one because there's multiple steps to it. So let's go ahead. Let's look first. I've got the square root here, and I've got a square root here. Well, I can't really do anything with this 1 minus because I can't move anything over yet. But what we can do is, since this one's already isolated, we can square this side and then make sure you square everything on this side. Now, once you do that, you're going to get 2x minus 5. Now, here's where it gets a little tricky. Since I kind of ran out of space, I did write this part up here. So what you're going to do is you're writing this twice, and you're going to distribute. So you get 1 times 1. You get 1 times negative root x minus 3. And then you're going to go negative x minus 3 times 1. And then now, since this is a negative and a negative, it's going to be a positive. And since you're doing 2 square roots, the 2 square roots are squared, so you're just left with x minus 3. So just be careful when you're distributing, especially with the radicals. So now let's combine our like terms. And then these two are actually like terms also, since they have the same radical. So we've got negative 2 x minus root x minus 3, because these are like terms. And then I've got plus x minus 2 because we combined the 1 and the negative 3. All right, so now we're going to try to isolate this radical by moving everything else over. So I'm going to move these two over to that side by subtracting x and adding 2. And then those cancel out. So now I've got x minus 3 equals negative 2 root x minus 3. Now I can divide both sides. Oops, sorry, I can't do that yet. I've got to get rid of this radical. Oh yeah, that's what, okay. So distribute this. Sorry, I skipped a step there. So distribute this, and you're going to get this. Okay, now I need to get the radical by itself. So what I'm going to do is, when I square this square is going to go to the negative 2. So it's really negative 2 squared. So that's where I got my positive 4. And then now this to the radical is left here. Okay, so now our radical's gone. We've distributed this to get that. And then now we can go ahead and distribute the 4. And now there's no more parentheses, no more radicals. Now we can just move everything over to the other side by doing the opposite. And I've got x squared minus 10x plus 21 equals 0. Now that you have the quadratic set equal to 0, factor, and you'll get x minus 7, x minus 3. So x equals 7 and x equals 3. So now we need to check. So we're going to substitute in 7 wherever you see x in the original equation. And here I've got 14 minus 5, which equals square root of 9, which is 3. And then over here I've got 4. So the square root of 4 is 2, and then bring everything else down. Well, I've got 3 equals negative 1. Well, that's not true, so that's why we cross that one out. So now let's try this one. Again, wherever you see x, we're going to substitute in 3. Oops, this one. I'm sorry, this one and this one. So we got 6 minus 5, which is 1. Square root of 1 is 1. And then square root of 0 is 0. So here I've got 1 equals 1. Check, we are good. So that is your answer, or that is the solution. So like I said, it's a little bit of doing something on one side and then combining terms, moving things to get your radical isolated. So in this case, we actually had to square it twice, here and here. And then once we finally got rid of all the radicals, then we could go ahead and solve it as we needed to. Okay, so you're going to go ahead, you're going to try number 8. And then what I would do is, in this case, is I would actually, for number 8, I would do this, but I would add so you're going to take this and move it to that side. Then once you can do it, then you can start to do all of the steps like what we did here. All right, So just remember when you're doing this, make sure you isolate the radical, and then of course always check your solutions. And that is solving square root equations.